So we're going to talk about congruence, namely in this instance congruence between triangles. So first let's just talk a little bit about what congruence means. This would be our symbol right here that we're going to use for congruence at all times. It's like an equal sign with a little swirly above it, but that's our symbol for congruence. So what we're actually saying here is that triangle ABC is congruent to triangle DEF. Now, what that means is that this triangle is congruent to that one. Actually, I have this set up here, and I'm going to talk about the symbolisms and the different parts and pieces of that here in a second. But the idea is that corresponding sides are equal, corresponding angles are equal. Now, that's what it means for these two triangles to be congruent. When we talk about the congruency itself, what it really refers to is same size, same shape. So since we're talking about something that's already the same shape, sides, that are equal. Now, it doesn't mean that all these sides are congruent to all of these sides. What it means is the corresponding sides are congruent. So what it means is that AB, line segment AB, is congruent to line segment DE. And we can write that. We can say that AB, the little bar above it, would be congruent to triangle, or congruent to line segment DE. Those two sides correspond. And we'll talk about why they correspond here in a second as well. We can also say that about all the angles. We can say that angle, we use a little less than looking symbol, which is angle, and I put a little curve on there to designate it as being different than a less than sign. Angle A is congruent to angle D. And we can say that about all the sides and all the angles. I'm just going to write these two down just as an example, though. But what does this mean? Well, it means that these two angles here are the same measurement. If this is 45, this is 45. If this is 10, this is also 10. If this has a measure of 7 centimeters, this has a measurement of 7 centimeters. So that these two sides correspond, and they're the same length because these two triangles are congruent. We can also make the argument the other direction, saying that these two sides are congruent, these two corresponding sides are congruent, these two corresponding sides are congruent, and so are these, which means that these triangles are congruent. Then it tells us the rest of the triangle as well. So we actually can start off with three pieces of information here, and we're going to deal with those in the next videos. It can tell us that that one triangle is congruent to the other triangle, which means that the other sides are congruent. So when we talk about congruent triangles, what we're referring to is that all corresponding sides are equal, and all corresponding angles are equal. And that's what it means for two triangles to be congruent. And we can prove triangles are congruent by starting with three pieces. And we're going to look at which three pieces. It really doesn't matter which three pieces. We can't just randomly pick some. But we need to do that. Now when we say corresponding, A corresponds to D, B corresponds to E, C corresponds to F. Why? Because that's the way we built it. All right? And a lot of things in mathematics are like that. It's like, why is that true? Because that's the way we built the system. Okay? D corresponds to A. And some of you say, well, why doesn't D correspond to B? Because D and B aren't congruent angles. So they can't correspond. A has to correspond to D. So you say, well, what if D and A correspond, but B and E aren't congruent? That means that B and E do not correspond. And if B is not congruent to F, then these two triangles don't have congruency. So there are some effects, there are some consequences, if you will, to things being congruent or not being congruent. So we can use that information to build up cases for other things. So it's actually quite useful to us. So yes, we can absolutely say that B and E are corresponding, but they're not equal, which means the triangles aren't equal. So if these two would have to correspond, but they're not congruent to each other, they don't have the same angle measurement, then we know these triangles are not congruent. But that's what it means for things to be congruent, is that we have these corresponding pieces that we can set up in some form or fashion that do this. Now when you're working with children, small children especially, notice I have these triangles set up in this particular manner. So they're actually lined up in the same format. Now they're definitely not the same length, right? I don't know if I can do that well. That's the old trick, right? Not the same length at all. The measurements are pretty close to each other, right? When you do this with small children, one of the first things you probably want to do is rearrange these so they're not necessarily in the same position in respect to each other. That way the children are forced to see well, how do these two match up? How do they correspond? Turn one 45 degrees or so, and that way you can really start to play with that. And I encourage you to do that as well. Put on two separate sheets of paper and just turn them. Turn one sheet of paper so you can still visually see that they're still the same shape and size. They're just what we call a different orientation. All right, so more videos about different types of congruencies that we can use coming up next. All right, take care.